feel the vibe.
Lesson here today as we continue our work with solving exponential and logarithmic equations. And today we are going to address a problem with the calculator that we have experienced when trying to evaluate logarithmic expressions, and we're going to solve it. And there was a reason that I held off until today so that we could develop some other skills, but now I'm going to show you a shortcut on how to use the calculator to solve any logarithmic expression using the change of base formula. So the problem that we encounter is that in a problem like we see here in 5a, we can't type that into the generic graphing calculator because when we type in the logarithm, it only gives us the option of base 10. To solve that problem, we can use what is called the change of base formula. So any logarithm of any base can be rewritten as a quotient or ratio of two other logarithms if we meet some very specific conditions. So let's say if we take log base a of b, I can rewrite this expression as any logarithm of b over any logarithm of any logarithm of a, as long as my base is a positive real number not equal to 0. So what this allows us to do is rewrite any logarithm into a format that can be computed in my calculator. So log base 3 of 29. If we tried to solve this by hand, we would let this equal x, and then say 3 to the x power equals 29, but then we would struggle to solve here because we don't know a power of 3 that would get us to 29. What we can now use is the change of base formula. So the change of base formula works by taking a logarithm of any base. Let's use log base 10 of the input, in this case 29, and dividing by a logarithm of that same base, log base 10, of the previous base 3. And so we can approximate, we can get the exact value. This is the exact value, but we can also now approximate this value. So log of 29 divided by log of 3 is approximately 3.07. If we round to, oh, sorry, it says the directions say to round to 4 decimals. Probably should have read that first. Round to 4 decimals. So 0.650. And then it says to verify our results. So let me show you that this does work. Remember that a logarithm is basically saying what exponent of 3 would give us 29. So I can take 3 to the power that I just wrote down using the answer button in my calculator and see that that is 29. So again, we can use any logarithm of any base. So let me show you a different way to write this expression. I could have written this expression as the natural log of 29 over the natural log of 3. Now watch me type that into the calculator. Natural log of 29 divided by the natural log of 3 is the same value. I could have written this as the natural log of base 6 of 29 over, log base 6 of 3. As long as my logarithms have the same base, it's still going to work. The reason we commonly use natural log and the common log in the change of base formula is because of the calculator. I can find those two buttons, those two values on the calculator. So let's take a look at another example. Example 5b, I could rewrite this as the natural log of the input 3.6 over the natural log of the base 5. This would be the exact expression. And then if I want to estimate this, this would be the natural log of 3.6 divided by the natural log of 5, which I can now put into my calculator, and it would be approximately 0.7959. And then I could check this. 5 to the power that I just had as my answer should be 3.6, and it is. So we can see here that the change of base formula allows us to evaluate any logarithmic expression in our calculator, regardless of the base. See if you can pause the video and complete problem 6. Hopefully you were able to get an answer for problem 5C. I said problem 6, but problem 5C And one method that you could use was to take the common log of 18 over the common log of 4. A logarithm of the input over the logarithm with the same base of the previous base. And if I type that into my calculator, sorry, I need to make sure I use the common log for both of these. But if I type this into my calculator, I get an approximate value of 2.0850. If I round the 9 would round up, rounding the 4 up. So again, I can check this by saying 4 is 4 to this power that I just came up with. Is that 18? And yes, it is. I have a slightly rounded answer, so a slightly rounded answer here. But this would be equivalent expressions for the expression given. This would have also worked if I used the natural log. So if you wrote this as the natural log of 18 over the natural log of 4, you can see that we would have the exact same rounded response and still be equivalent expressions. So the change of base formula is going to solve a lot of problems for you guys here moving forward. It gives us an opportunity to evaluate any logarithmic expression in the calculator. As always, thank you guys for tuning in, and I'll see you soon.